In this video, you will be presented with an overview of a .NET Azure App Service Diagnose and Solve Problems Generated .NET Profiler Trace report, which was captured to diagnose a hung request. Additionally, the manual analysis of the same trace using PerView on your local machine is provided. It is expected that you have already downloaded the .NET Profiler Trace and PerView. A link to the video showing how to capture this .NET Profiler trace is provided in the description below, as is a link to the official PerView download GitHub repository. Select the web link icon next to the instance name to open the .NET Profiler Trace analysis report. Notice the breakdown of the time spent in request execution between application code, platform, and network. Notice the list of slowest requests, which provides a very clear indicator of which request is hanging. Navigate through the different tabs and analyze the findings. For example, .NET Core slow requests, failed requests, thread call stacks, .NET Core exceptions, and CPU stacks. Select the .NET Core Slow Request tab. Scroll down until you find the name that showed as slow on the slow request. Make note of the activity ID. Provide the name of the slow request to the party owning this application and have them investigate the code. To analyze the .NET Profiler trace locally, open the .diag session file in PerView. Double-click the .diag session file. It will take a few moments to load, so please be patient. Once loaded, double-click or expand the diag session file to expose the ETL file. Double-click the ETL file. Double-click thread time with start-stop activity stacks. Notice the .NET process and the command line value that includes a non-Microsoft assembly, both of which are areas of interest. Select the Activities checkbox. Recall the .NET Core Slow Request tab from the Analysis report. Take a look at the activity ID 6936/1/4/13. Navigate into the activity, check by check, until you reach the non-Microsoft assembly. From here, you can see the page name and the methods in which it is calling. Alternatively, you can place the name of the slow page identified in the analysis report and search for it. Low CPU hang, which results in the same conclusion. Provide this input to the party owning the assembly and have them investigate the code. And finally, but extremely important, is to recognize that memory dumps and .NET traces contain very sensitive information. Take extreme precautions and follow documented procedures for handling these files. Remove them from all devices once they are no longer needed.